Hi Pre-Cal students, we are looking at Law of Sines today, lesson 15-2. And so Law of Sines is pretty straightforward. The Law of Sines defines the relationship between sides and angles in any triangle. So what's different here is that we're not talking about strictly right triangles anymore. This will work for any triangle, and that's the power of it. And it's very simple. It simply says in triangle ABC, the sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. All those ratios are equal to each other. So I'm going to take just a few minutes here to kind of show you how we can prove this. All right. So I have just a general triangle here, ABC, clearly not a right triangle, and we're going to draw a height here between that's perpendicular to the opposite side from angle B down to this opposite side, and we're going to call this side down here B. B is going to stretch from, angle C over to angle A here. And then opposite of angle A, this side over here, we're going to call small a, and opposite angle C, we're going to call that small c. All right? So, using the right triangle formed by H, I can define sine of angle A as opposite over hypotenuse, that would be H over C. Likewise, I can define sine of angle C over here, using the right triangle, as H over A. And since both of these have a common variable of H, I'm going to solve for H. So I'm going to multiply times C on both of these, and I get H is equal to C sine A. And same thing here, I'm going to multiply both sides by A to get the H by itself. And H is equal to A sine C. And we're talking about the same H here. H is equal to C sine A. H is also equal to A sine C. Well, if they're both equal to H, I can put those equal to each other. That's called the transitive property. And we'll say C sine A is equal to A sine C. And then I'm going to divide both sides by little ac. Divide by little ac. On the left, my c's are going to cancel. And I have sine capital A over little a. On the right, my little a's are going to cancel, and I've got sine C over little c. And there we go. We've got 2/3 of what we wanted here. Sine A over A is equal to sine C over C. And we could also go through and prove that it's also equal to sine B over B. Okay? So we have done at least part of the proof here. Okay, so when can we use law of sines? Well, we can use law of sines in two situations. In this situation, it can be used. Law of sines can be used to solve triangle problems where a side angle pair is known. What we mean by that is that I know both angle A and side A, or angle B and side B, or angle C and side C, and I know one other side or angle. So I have to have both A's, both B's, or both C's, and one more piece of information. If I have that situation, I can use law of sines. So let's put it into action here. Let's look at number one. Find all missing parts for the triangle given. You can see I've got angle B is equal to 35 degrees and little b is equal to 9. So I've got both the angle pairs, the side angle pair for B, and then I've got one more piece of information. I know that angle C is 50 degrees. So I'm just going to kind of draw this in some kind of general triangle. It doesn't have to match what we have here. And I'm going to label my angles A, B, and C. And angle B is 35 degrees, angle C is 50 degrees, and side B, which is opposite angle B, is 9. So we want to find three things. We want to find angle A, we want to find little a, and little c. Well, angle A is easy because I know that the three angles of a triangle add up to 180. I can say that angle A is equal to 180 minus, minus should have been outside the parentheses, minus 35 degrees plus 50 degrees. Okay, so 35 plus 50 is 85, and 180 minus 85 is equal to 95 degrees. And there's my first piece of information. Angle A is 95 degrees. All right, now I can use the fact that I have angle B and side B. I can say sine B over little b, 9. Well, let's leave it as letters right now. Sine B over B is equal to sine c over c. Let's just do b and c first. So plugging in, sine of 35 degrees over 9 is equal to sine 50 degrees over little c. I'm going to cross multiply here, and I get c sine 35 degrees is equal to 9 sine 50 degrees. Kind of going off to the side here a little bit, but if I divide both sides by sine 35, I've got c is equal to 9 sine 50 over sine 35. And that is, put that in your calculator, make sure you're in degree mode. That is 12.020. We're always going to round the sides to 3 decimals. All right, let's do A now. I could use C and C now, but since this is an approximation, I'd rather use the exact values. So I'm going to say sine A over little a is equal to sine B over little b. I know that capital A is 95 degrees. Sine 95 over little a, I don't know that, is equal to sine B. My B is 35 degrees. Over little b is 9. Again, cross multiply. 9 sine 95 equals a sine 35. Divide both, to get that a by itself, I'm going to divide both sides by sine 35. So my little a is equal to 9 sine 95 divided by sine 35. In your calculator, you should get that that is 15.631. One thing I might point out here, the triangle inequality, remember that the bigger the angle, the opposite side is going to be larger. So since A is my biggest angle, it's got to have the largest opposite side, 15.631. Next would be C. C is the second biggest angle, and it is the second biggest side. And then the smallest angle is actually B, which has a side of 9. And so that fits okay. All right. One more example here. Number 2. A is equal to 10, C equals 7, and C is equal to 30 degrees. So we have both C's here. So this time I cannot figure out my third angle yet. We're going to have to solve for the angles in just a minute. But the first thing I'll have to do is solve for angle A. I have no choice in this matter. But let's go on and draw a picture here. And again, I'm just going to draw kind of a generic triangle ABC. Put in what I know. C is 30 degrees. Small c is 7. Small a is 10. And I'm looking for side B and then angle A and angle B. So I've got to solve for angle A first. So let's do that down here. Sine of A over 10, its opposite side, equals sine of 30 degrees over 7. So on this one, I'm just going to multiply both sides by 10. If you want to cross multiply and then divide, that'll work fine. But to get sine A by itself, if I multiply by 10, I get sine A is equal to 10 sine 30 degrees over 7. And so A is going to be inverse sine of 10 sine 30 degrees divided by 7. And so angle A is approximately, we're going to round these to 1 decimal place, and this comes out to be about 45.6 degrees. 45.6 degrees. Okay, so now that I have angle A, I can find angle B by subtracting from 180. So I've got 180 degrees minus 45.6 degrees plus 30 degrees. And all that's going to give me that angle B is equal to 104.4 degrees. So I've got A and B, my angles. My last thing is I want to find side B. So I'm going to say sine of, actually let me just go and put 104.4 here, 104.4 degrees over little b. And again, I'm going to use C since those are exact numbers. I know sine 30 degrees over 7. It'll probably come pretty close. If I use the 45.6 and 10, it would come pretty close, but this will be more exact. I'm going to multiply this time I'm going to cross cancel. I'm going to cross multiply. So b times sine 30 is equal to 7 sine 104.4. And divide both sides by sine 30. And I get that b equals 7 sine 104.4 degrees divided by sine 30 degrees. And little b is 13.560. It's the biggest angle. It's the biggest side. So that I like that. Okay? That's it. I hope you are doing well. If you have any questions, send me an email. And I'll talk to you later. Bye-bye.